Yeah, good evening, everyone. Can you hear me? You can hear me. Just say hi. Good evening. Good evening. It's good to have this Wednesday again. Our teacher is stuck in traffic, so hopefully before our break will be ready, I'll hand over to you. I just had to quickly put myself in order. Where, all right. Hi, everyone. Good that you can hear me. So because of our time, quickly I'll go. I need to first apologize to everyone. I got a message not quite long that is all in traffic. Sorry about that. I apologize for that. When it comes in, we will take over the class. But pending that, let's go on. So today we'll be looking at data cleaning, handling missing values, removing duplicates, and fixing data types in Python. All right. Thank you. So data cleaning. What is data? What's the first question that comes to your mind when you ask the question, what is data? What is data? I'll need our responses online. What is data? We talk about data set. What are we talking about? What is data? Just three comments there. We go on quickly. Somebody says information. All right, I need more responses. What is data? Data is information, sequence of characters. Yeah. Any other? Data is raw facts or processed information. Right. Wait. All right. Okay. I'll say you are all correct. Let's go. So data is any collection of facts, figures, symbol or observations that can be recorded and analyzed. Yes, if you have said unprocessed, it is raw, you are correct. But we look at it as any collection of facts, figures, symbols or observations that can be recorded and analyzed. Yes, raw facts. Then when you transform it, it becomes what? Information. It can be qualitative, that is like descriptive, like colors of it, and it can be quantitative, like numerical value, or like height or age. So when somebody asks you data, we have gone beyond talking about raw information or processed information. So it becomes facts. Somebody says statistics, exactly, often in numerical or categorical form, used for analysis, research, or decision making. Yeah, great, Sola. That is fantastic. So data has gone beyond just raw information or raw data that needs to be processed. There are facts, there are figures, there are symbols, there are statistics, either in categorical or what numerical form, which we call either qualitative or quantitative, form. All right, let's move on. Complete information, you're correct. You're correct. You're correct. Okay. So when you look at this now, can you see the picture of the AI? So the AI is like a mirroring what our brain using a what neural networks. Then you have the intermediary, the LML that help us what to convert that data into what required information. That's just what this image is talking about. Doctors, this is not data analysis class. This is AI ML class. All right. So in ML, when we talk about data in AI ML, it is the foundation of everything that we are doing. I think I mentioned that when I started class two. Yes, when I spoke about module two. Without data sets, we can do nothing in AI ML. It is data that we transform, that we use in training our models to give us what desired output. So without data, there's nothing like AI ML. All right. I say machine learns patterns and makes decision based on it. If your data is poor or messy, your model's result will be true. I said when somebody was asking, what is the meaning of garbage in, garbage out? It's as simple as that. Whatever you feed your model is what your model will give to you. You feed your model with imbalanced data set, or data sets that you have not removed missing values and things like that. Then you get into also, you found out that your model is not generalizable. When I mean generalizable, it's not working on all platforms. In fact, it won't even get to the issue of generalizability. You will have data that is either what underperforming or what? Sorry, a model that is underperforming or what? Overperforming. So when you start working your practical, you learn things like overfitting and underfitting. Sometimes the issue comes from your data sets. In fact, most of the issue, if you are not careful when you're working with your model, comes with your what? It comes with your uh, data. Comes with your data. All right. If you can't hear me, let me know. Somebody is saying, "Am I the only one not hearing?" Can everybody hear me? Just somebody let me know if you can hear me, so we can go on. Hello. Audio is good, fantastic. So let's go on. Let's go on. Thank you very much. So, what is data cleaning? This brings us to data cleaning. So, for our data to be viable, for our data to be useful, for our data to do what it is supposed to do, for our data to give us outputs that can be generalizable, outputs that meets global standard, then you need to clean your data. And that's what brings us to what data cleaning. And I say here, the data cleaning is the process of correcting or removing corrupt, inaccurate, incomplete, or irrelevant records from your data set. It's as simple as that. You are either removing missing values, in fact, handling missing values, sorting rows, removing rows that are not useful, organizing your data. Maybe your data is having you are working on numerical data and you have categorical data. There, you need to change. You need to convert from categorical data to numerical data, or convert from numerical data to categorical data. So it's it's a very fantastic thing when we are doing that. It looks as if also we are also doing what analysis. Analysis. If you can't hear me, you might need to work on your network. I know I'm actually getting my feedback and I can hear myself as loud as possible. So if you can't hear me, you need to check your network connection. All right, let's go on. Thank you. So data cleaning. Why is data cleaning important in ML? Why, in fact, in AL, ML? I say machine learning models are highly sensitive to what? Bad data. Quality input equals what? Quality output. Just like everything I've been saying, garbage in, garbage out. And if you have rubbish input, also you will get what? Rubbish output. It's as simple as that. And that is why we perform a bit of data what, analysis before we start feeding our models into feeding our data into our models, doing the test split train and any other thing that we need to do. You must clean your data set. Then what else again? It helps avoid misleading conclusions and poor model performance. Yes, yes. There was a project I just recently finished. I think I finished this morning and I had to submit the paper. When I did it, it gave me a fantastic accuracy because that's one of the mistakes people make. When you create a model and you're having accuracy of like 97, excuse me, and you're having an accuracy of 98, people are like, wow, wow, I've done fantastically well. My model is working. I'm telling you, we subject it to some tests. Then we realize that your model is overfitting, it's overworking. All right. So I'll keep on talking on now. Then your lecturer is here, so he will come in. He will step in. So Mr. Isaac is here now. All right. So let me finish this slide. Then Mr. Isaac will take over from the rest. So like I was saying, misleading conclusions. Okay. Okay, it's coming in now. All right. So maybe he comes in. He turns on his video. I will leave so that you will continue. So you find out that your Mr. Isaac, you can turn on your video and comment. So I can just round up this slide and hand over to you. All right, so okay. So your lecturer is here. So sorry again for keeping you guys waiting. Over to you, Mr. Isaac. Thank you.
All right, thank you very much, Mr. Wole. Thank you very much. I really appreciate it. Apologies for coming a bit late. I hope everyone has been enjoying the class so far, and I'm glad to be with everyone again. All right. All right. Thank you very much, Administrator. All right. So thank you very much, Mr. Wale, once again. So we are discussing about data cleaning, handling missing values, removing duplicates, fixing data types in Python. I know Mr. Wale has taken us through some of the slides, so I'll just continue from where he stopped. But before I continue, I would like to reiterate on some of the things that are involved. In our last class, we discussed about we started with Python, right? So we started discussing about what Python really is, some of the functions, the variables, the data types, and what have you. So, and Mr. Blessed also helped us with more practicals, right? Like I mentioned last week, and I know that has given us an in-depth view of what it really is, right? So I'll take it up from here. Data cleaning. Why is it important in artificial intelligence and machine learning? Now, machine learning models are highly sensitive to bad data, and quality inputs would also lead to quality outputs. So I know we've heard about garbage in, garbage out. Exactly the same principle. So whatever you give to this to the model is what to work on and produce that parallel, or let me say the same quality of the output. So the quality of input you give to your model will determine the quality of the output that you will get at the end of the operation of the processing. So it helps avoid misleading conclusions and poor model performance. So let me give an example. Now, let's say we have a model. I want to feed the model with, let's say, date of birth, starting with the year, the month, and the day, right? So if we are feeding that to the model, and then we'll tell the model to, okay, let's say, let me say, the height, for example. This is a very simple example, not really a substantial example, but I just want to illustrate something. So let's say we need the date of birth of everyone with their height. So we're feeding the model with that information. Now we want the model to predict based on a height. So I give it, let's say, 6 feet. It can determine or predict, right, the age of that person. So just a rough example. So let's say now with that data that we're going to feed the model, let's say for example we have some that don't have the year, some that don't have the day, some that don't have the month, and we need all this information to determine the age. Let's say some of those data now don't have those values. On the long run, the model will not be able to predict well because it didn't have or get sufficient quality data to work on. So data cleaning is very, very important in machine learning because if our data is bad, we definitely get a bad result. So AI model or AI tools that we have today that are running properly well is because those models were fed with rich and quality data. So let's look at this reward example together. So we say survey responses with blank fields. Let's say sales data with duplicate customer entries, for like just like the example I gave recently. So a spreadsheet where date is written as 13/February in one row, and in the other one we have 2024 February 13th. So there are two different things. So if we have such errors, such discrepancies in our data, we need to clean them up before feeding them into our data. Handling missing values. So missing data occurs when no value is stored for a variable in an observation. Missing data occurs when no value is stored for a variable in an observation. So now, I remember we mentioned about variable, we talked about variable in our last class. So variable is just like a container that holds a value. It's a container that holds a value. So they say, how do we now handle missing? So missing data occurs when no value is stored for a variable. That means a container that don't have a value in an observation. So that's the missing data. We have the container, we have the space, but no value is inside. Okay, let's proceed. So now, how do we undo missing data? We have a data set, right? All the data sets, among all the data sets, we have some that are missing. So how do we handle such error so that we don't feed our model with erroneous data for it to produce quality result? Because if you give it erroneous data, definitely we're going to get an erroneous result. So number one, remove rows or columns with missing data. So by doing that, we might actually reduce our data, the number of data we have, right? But then it is good, it is better than having the data that will not be good enough for the model to work on. So removing those columns that have missing data is actually a good way and a technique to handle missing data in our data set. All right, moving on. Another technique is filling values, that's the imputation. We have the mean and median imputation for numerical columns. That is for data sets that are numbers. We have the mean and median imputation. We have the mode imputation that's for categorical data, and we have unknown, not provided, or null. Yeah, we also have null for text fields. Okay, let's continue. So the third technique is predictive imputation. It is more advanced. So this is when the model itself can identify that this data is not accurate. There's something wrong with this data, and then it can predict the missing value for that empty space. So that is the third technique, predictive imputation. So it is more advanced, using machine learning models to predict missing values. So all these techniques are very important because by the time we start building our model, we see the importance of these things because we can't feed, like I said, we can't feed a model with data that is incorrect and expect incorrect results. It is never possible. It is garbage in, garbage out. It does its work, it does the processing, but then you have to do your own part by feeding it with the right data. And thanks to computing, because there are some models now that can actually predict missing values, can predict missing data. But then, not every one of them, right? Not every one of them. And there are some information that would also require us to put in correct data, right? So another technique is leave as is. So this is telling us that we don't need to actually remove data, probably because we have some missing values, right? But because some of these algorithms, some algorithms, like just like the predictive, but this one has some algorithms that can actually undo those omissions. So like XGBoost, for example. So this is a real world analogy. So imagine you are filling out an application form and leave the email address blank. That's a missing value. So that email address is a variable, is a container that needs to hold a data, that needs to hold a value, right? But if that value is missing, then we have an omission. There's a missing value, there's a missing data because that variable doesn't have a value. Okay, so we've discussed about missing values. They are very crucial to be addressed. They should be crucially addressed while preparing our data for the model. Another one again is duplicates. Duplicates. So duplicates, unlike missing values, duplicates is like having the same record more than once in your data. So what is a duplicate? Just like the word duplicate, right? So duplicate records are rows that represent the same entity more than once. I come again. Duplicate records are rows. Now we know our rows, we know our column. So our rows is from left to right, our column is from top to bottom, right? So Duplicate records are rows that represent the same entity more than once. For example, let's say we have a table from top to bottom now, from left to right rather, from left to right now, we have the name, we have the age, we have let's say date of birth, and we have email address, right? So let's say the first list we have Isaac, we have the age, we have the email address, right? And let's say on the next row we have Joshua, we have date of birth, we have email address. Let's say on the third row we now have Isaac again, the date of birth, and then the date of birth and then the email, right? Because of we have that value on the first row and we have it again on the third row, that is a duplicate record, and it is very bad for our model to work with. So removing duplicate record is actually very important in starting off with building your model. Okay, why does it matter? Sorry. Okay. 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 So why does it matter? So duplicate inflates statistics and distorts analysis. For example, let's say that Isaac data that we have in the first row and in the third row, let's say we have it in other 100 rows. That will actually inflate the statistics of that data set, right? Because we have that row, the same thing, the same Isaac, the same date of birth value, the same email address. Now having it on several other rows, that will inflate actually the statistics of the data set. It also leads to bias in model training. Yeah. So when you're training your model with duplicate data, it will lead to bias because the model would have seen that same data multiple times, right? So it can lead to over representation. All right, let me give an example. So let's say in an online store's customer database, the same customer's name appears twice with slightly different emails. Okay, this can result in misleading customer insights. Yes, so this is also a very good example. This is also another example of duplicate record. So, and removing these duplicates will actually be good for us to feed our data with the correct and accurate data without the duplicate. Now, fixing data types. I remember in our last class, we also talked about data types. We have the integer data types. I can't see our comments on YouTube. I would have been asking questions, but I think it's good. Okay. Data types, we have the integer data types, we have the floating data types, we have the boolean and some other ones that we discussed last week. So why data types matter? Why do we need data types? So incorrect data types can prevent calculations, it can cause error in modeling and distort statistical measures. For example, say incorrect data can prevent calculations. Let's say we want to add two numbers. Okay, yes, we want to add two numbers. So let's take variable A as one variable, variable B as another variable. So if we put, variables are containers that hold values. Now, 2 is a value, 3 is a value, Isaac is a value, yes, Isaac is a string, 2 is an integer, and other types like that. So let's say variable A now is holding Isaac. Isaac is a value. And let's say variable B is holding 2. And what we want to do is that we want to add variable A and variable 2 and variable B together. That would not take place because variable A is not an integer, it is a string, and variable B is an integer too. So adding them together will bring an error because they are of different data types. So we can now say, okay, variable A should be integer 2, variable B should be integer 2. Now, if we are trying to perform an addition operation on the two variables, it will be successful because both of them are of the same data types. So data types are very important in Python or in programming, in building your model, because you would need to perform some operations or some other statistical computations that will require you to have the correct values in your variable before performing those operations to prevent errors. So let me come again. Incorrect data types can prevent calculations, cause errors in modeling, and distort statistical measures. So let's keep this at the back of our mind that anytime we are writing our code, we are writing our Python script, let's remember that data types are very important, because whenever we are performing operations or carrying out computations, whenever data types do not match, there might be some errors. So data types is very important, not even only in Python, in other programming languages as well. So data type is very important. Okay, moving on. We're still on fixing data types now. So common fixes, exactly, is a very good one. So converting string numbers to integers or floats. Yes. So I wish I can see our comments right now. Okay. So for example, 25 in double quotes, you see the forward arrow, then 25. The first 25 is not an integer, it is a string, because it's inside those double quotes, right? So anything in the double quote like that, they are strings, and then the other one standing on its own is an integer. So if we have 25 dot zero, that will be a floating number. That will be float data type, because it has the decimal. I remember we discussed about this in our last meeting. Just to reiterate, so we have to convert whenever there are data types mismatch. You we need to convert. We need to convert. So let me give this as an example again. Let's say variable A is this first 25, this first one, and variable B is this second one, right? We can't perform an operation because this is a string, while this is an integer. It will give us an error, irrespective of the fact that they are both 25. This is a string 25, this is an integer 25. So for us to perform a successful operation, we need to convert this to an integer. All right, we have to convert this to an integer. So convert text date into date time format. Yes, this is also another very good example of fixing data types. So we can convert date that were being collected in text. For example, let's say I think there was an example. Sorry, there was an example that I presented the other time. Yeah, something like this now. So if we have this in our data, we can always convert this to date time type. So that would also help us in handling data type error. Another example is Boolean values. So the Boolean can either take true or false. That's 1 or 0, right? So we can convert our data that has yes or no to 1 or 0. So that will really help our model to understand better. So either 1 or 0, or true or false. So 1 represents true, 0 represents false. All right, moving on. This is a very good example. So if price is stored as a string instead of a number, you can't calculate average prices. Very good example. So let's say we have price 1, 100, price 2, 300, price 3, 400, and all of them, those values, those 100, 200, 400, are in quotes, double in quotation, this thing like this. They are all strings, they are not integers. So you can't really perform you can't calculate the average price for those values. It will give you an error. And but I think on Friday you guys will practicalize the whole thing. So this is just the theoretical class, so that we understand and prepare the ground for our practicals. So data type is very important. We need to convert them whenever they are needed, whenever they are not in the right state to be used. Yeah. Okay. So data cleaning workflow. We have several types of cleaning our data. So the first one is this is the workflow actually. So the first one is understanding the data. You have to understand the data. So we can use functions like info and describe. So this will give us the information about our data. I think describe will give us the mean and all those things, the statistical qualities or properties of that data. Info will also give us the description of that data. Yes, so understanding the data set is very important. You need to understand your data set. What are you working on? What are you working with? How do you feed them? what is the modality of your data? Yeah, so you need to understand the data that you're working with. Now, another workflow process is to identify missing, inconsistent, and incorrect data. You know, we've discussed that it is not a bad thing to have missing data or inconsistent data. You know, data is something that you source from several places. For example, you can get data via filling sending out a survey. You can get data from several means: social media, um, maybe word of mouth, several means. So there's a high chance that data error can come in, omissions can come in, inconsistency can come in, duplicates can come in. So you have to identify these challenges, these problems in your data. You need to identify them. So another workflow process is to apply the appropriate cleaning strategies, right? To apply the appropriate cleaning strategies. We discussed some of them earlier. We have the yes, we have this: the predictive, the imputation, the removal, and what have you. So we need to apply the right one that would be useful for our data set. After understanding the data set and identifying the problem, then we will now apply the appropriate cleaning strategies. The last one I have on my slide is to validate the data quality. You have to understand that you have to be sure that this data you are using, they are of good quality, right? Before feeding them into your ML model, your machine learning model. So you have to understand, you have to identify problems, anomalies, you have to apply the appropriate strategy, and you have to validate your data that they are of good quality before feeding them into your model. Moving on. So have you ever worked with messy data? I want us to drop it in the comment section while I get my other device so that I can follow through with our comments. So let's drop it in the comment section on YouTube. Have you ever worked with messy data? Let's discuss. Let's see how far we've experienced messy data. So have you ever worked with messy data, or have you seen a messy data? Have you experienced? Have you come across a messy data? You know, data that has, for example, under the email address field, you have maybe name that can be very messy. Let's say on the name field, you're having phone number that can be very messy. Or let's say your email address, instead of, for example, Isaac at gmail.com, you're having Isaac at without the gmail.com. That can be very messy as well. So let's drop it in the comment section if you've worked on or worked with or experienced or seen messy data. I'm trying to get on YouTube now. Okay. Right. Yes, I've worked with messy data. Okay. Yes, I've seen data where the customer is supposed to put their email in the form, but their name, because there's no proper form validation. Excellent. So form validation is also a way of actually preventing. Yes. So if you're getting a data probably via a form, it's a way of preventing, bad data, because the validation we check, for example, for email, is there alert, right? So it is checking. So that's a very good one. So unnecessary space in the full name field. Excellent. That can be very messy. That can be very messy. Very frustrating. Yes. Yes, that can be very frustrating as well. Um, I've worked with it a lot on missing entries. Yes. So those type of data, okay, sorry. So those type of data can be very, very messy. All right. So moving on. Yeah. So this is a very good example. A very, very good example. So we have the first name, we have the last name, we have the email address, and we have the date. So we can see for the first row, we have Isaac, we have for the first name, then we have for the last name Oyekule, we have the email address, we have the date. We can see that the first row actually looks very okay, right? The name, the first name is complete, the last name is complete, the email has an at, it is correct. It has the date format is also very good, the year, the month, and then the day, right? It's also very good. It looks very cool. Let's move on to the second row. On our second row, we have Joshua. We have Joshua as the first name. We have Ebuka as the last name, and then we have Ebuka under the email feed, just Ebuka alone. And we all know, we are all sure, right, that Ebuka alone cannot just be an email address. That is invalid. That is an inconsistent data, is an incorrect data, right? So, and the date for the second row is actually not bad. Yeah, it takes a proper structure. That is the year, the month, and then the day. So let's look at the third data together. We have Daniel as the first name. We have Amzat as the last name, and then the email address. Email address we have dham@gmail.com, and then we have the date as 30th April 25. So we can say this is a data set that has three rows and four columns, right? This is a data set, but this data set is not clean. It is not clean because we have inconsistent All right, awesome. So we are back up. Have you ever worked with messy data? I know most of us have replied. We've dropped our comments on the YouTube channel. And I've seen so many comments, right? People said they had messy data because of lack of validation. Some people had duplicate records and all those things. So they are good problems, right? Because we can now understand this course properly because of those experiences. So we need to handle those messy data before we feed our ML model with those data. So we've explained this, the data sets, that is the inconsistency and different ways in which we can handle missing data or inconsistent data in our data sets before feeding it into our model. So we're going on a short break to take our attendance. But before we go, and while we're on the break, I would like us to drop our questions so that by the time we come back from the short break, we'll be able to answer those questions and then move on to the next topic. So please drop in your questions. We'll be going on a short break now for our attendance. While we are going and while we are on the break, just drop in your questions. I'll take note of them. Once we come back again, I'm going to answer the questions and then we'll go straight right into our next topic. Thank you very much, everyone. Have a wonderful class ahead. Yeah, welcome back, everyone. I hope you enjoyed the short break, and I hope we were able to feel our attendance. Okay, so I want to read out some of the questions that we asked. So we have, I think I saw one quickly. All right. Elaine said, "How do we practically clean the messy data from the example you gave?" Awesome. So for the practical session, we'll be having it on Friday, right? So this is just to prepare you for the practicals. So this will give you the theoretical insight and to give you the understanding of why we are cleaning data, the different workflows, the different types and methods of cleaning your data. Yeah, so this is to prepare you for the practical. Okay, which other question? Exactly, Mr. Shegun Gabriel. He said something really profound. He said, "You cannot train a model without data, and you must ensure the accuracy of those data. It is just part of what we should know." Awesome. So you cannot train a machine learning model without a good data, right? To get a good result. So you have to understand your data, like we said. You have to um, understand the inconsistencies. You have to apply the appropriate method to, attack the inconsistencies, be it missing data or inconsistency in a particular column or any other one. So you have to clean up your data before feeding it into the machine learning model. The network is not friendly at all. Sorry about that. Um, okay, what textbook do you recommend we should have as a beginner? You can get any textbook online actually, and with this you can also go through the slides again. I know DSC is going to provide it. The Incubator is going to provide it again to you guys on the LMS platform, so you can go over it again. You can check online for other resources. You can also check ETC Vibes. So I have a course on ETC Vibes that you can also go through. You can see AI machine learning courses as well there and just read through and get some more insights. So yeah, that's basically, you can always get materials all over the place. So we'll be moving on to our next topic. So summary statistics. Like I said, you have to understand your data. You have to know what you are working with, the modality, the properties, the attributes, and everything about your data set. You need to understand it because it will be very useful while building or training your model. So what are summary statistics? Summary statistics are numbers that give insight into the central tendency, spread, and the relationships in a data set. I repeat, summary statistics are numbers that give insight into the central tendency, spread, and relationships in a data set. We're going to, not to confuse anybody, we're still going to understand it better. So moving on, why does it matter? So why does summary statistics matter in machine learning? Number one, it helps understand data distribution. So the summary statistics help us to understand how our data is being distributed. We have several types of data. We have numerical data. We have different types. So these summary statistics would help us to understand the data distribution. Number two, it will help us to detect outliers and anomalies. Right? We can have some data that are not correlating with the rest of our data. So it can help us. For example, um, let's say we have a result sheet. Let's say we have 5 people on the sheet. Let's say 4 people from the 5 people have, let's say they scored, let's say 70%, right? And then let's say the fifth person now scores like 1000%. So that is an anomaly, that is an outlier. There's a problem with that data. So some statistics will help us to detect such problems. So they are very important. So why summary statistics in machine learning? The third point is it guides feature engineering and pre-processing. I'm sure Blessing touched a little about this, the processing, but we're still going to dwell on it more in our practical classes. Pre-processing is very important, and this some statistics can also help us with these processes. So the fourth one on my list is informs models choice. So as summary statistics will also help us in our model choices. So is it linear, is it non-linear, and the other ones. So summary statistics will help us to inform us about our model choice. Now, we're going to pick some of these summary statistics one after the other. I'm very sure that we are familiar with some of them, at least majority of us, because there are things that we've done in probably primary school or secondary school or in the university. So I remember back then, some people would say, why are we doing this thing in class now? Why are we doing mean? Why are we doing average? Are we going to use them in life? Yes, you're going to use them as long as you want to go into machine learning and artificial intelligence. You will need all these statistical analysis of or properties or operations. Yeah. So we have the mean. Mean is very popular. We all know mean, and mean is an average. So on my slide, I have it that mean is the sum of all values divided by the count. Very simple. For example, I gave an example of 5 students earlier that they have 70%, student 2 70%, student 3 70%, student 4 70%, for example, and student 5 1000%, right? So I was using that, I gave that to illustrate the anomalies and outliers in our data, right? So now I want to use that same example for our mean. So to calculate the mean of the 5 students, we have to sum student 1 scores, student 2 scores, student 3 score, student 4 score, and student 5 score. So we're going to sum everything together and divide it by the number of students. So that is 70 plus 70 plus 70 plus 70 plus 1000 divided by 5. That will give us our mean. Very, very easy. Very, very easy. All right. So what are the advantages of the mean? So why do we need mean? Why? We all know that mean, like I said in my previous slide, is the average divided by, so the average are the sum of the total, the sum of everything divided by the count, right? So what is now the advantage? The first one on my slide is it is simple and widely used. Mean is very simple and widely used. So just the total number divided by the count. Very simple, very easy to do. So mean is very important. It is very good. Another example, another importance of the mean is that it is good for symmetrical data. It is good for symmetrical data. Now, moving on, what are the cons? So, it's affected by outliers. It is affected by outliers. So, let me explain that again. So, let me use that same example of 5 students. One is scoring, one has a score of 70, the second one 70, the third one 70, the fourth one 70, and the last one 1000, right? So if we should calculate the mean, that's 70 plus 70 plus 70 plus 70 plus 1000 divided by 5, the value we would get will be different from when we have, let's say, 70, 70, 70, 70, 80. That last one is far apart. It will definitely affect the mean after computation. So that's the disadvantage that we can get from computing the mean. All right. So example, if 9 students score 70 and one scores 10, I repeat, if 9 students score 70 and one scores 10, the average may not represent most students well. It will not, because we have an outlier, right? The normal students score 70, 70, 70, 70, 70, 70, 9 of them. Then the last one is scoring 10. That is, the gap is too much. So if we compute the mean, it may not necessarily represent the average. Yeah. So that is a very good example of mean computation, and then the advantages and the disadvantage. Okay, so the next one is the median. I know whenever we hear mean, that's the previous one we just discussed about. The next thing that comes to our mind is median, and the next one is mode. So yeah, so what is median? Median is the middle value when data is sorted. Median is the middle value when data is sorted. So it's just representing the mid value, right, in our data set. What are the advantages? It is resistant to outliers because we're looking at the mid value. It is better for skewed data that are not straightforward, data that are probably more on one end than the other end. All right, so example. So income distribution is a very good example. Now, reading what I have on my slide, if most people earn 50,000 naira per month, but one CEO earns 500,000 per month, the median gives a better picture of a typical income. So the mid value of this particular distribution will give us the typical income of this particular data set, if we're trying to get that. So mode is the third one. Mode. Mode is the value that appears the most. It is the value that appears most often. It is the highest, yes, the most the highest occurrence, right? So it is useful for categorical data, e.g., most common gender, location, product category, and the likes. So mode is very useful. Somebody said in the comments that so the math I ran away from caught me here. All right, so those things were being taught in school are not just for the fun of it, actually. So we use most of these things, especially in computations like AI, machine learning model development, or training, or whatever. So we use most of this or some of these things for these computations. So we still have our mean, we have our median, we have our mode. They are not very difficult. They are not difficult things. They are very simple things. And on Friday, by God's grace, we are going to see the practical display of these things. Very easy. So I remember, if you remember back then in school, you were doing the computation yourself on your black and white, right? But this, the computer does it for you. Just give it the data set and the command it to perform the operation. It does it clean and fast. So you don't need to stress or you don't need to be worried that they're going to come to calculate to calculate. No. So, but then having an idea, having an understanding of these things will help you understand how your operations is how your operations are being carried out by the computer when you're running your model. So the mode is the value that appears most often. It is useful for categorical data. For example, the gender, location, product category, and some other ones. Okay, so we're moving on to the advanced one now. So we've discussed about mean as the average. We've discussed about median as the middle one. We've discussed about mode as the highest, the ones that occurred the most. All right. So variance and standard deviation is the next one. So variance shows how much data varies from the mean. I repeat, variance shows how much data varies from the mean. So we have two. We have the high variance and the low variance. So the high variance is that data is spread out. You know, the variance, it shows how much data varies from the mean, right? So we know the mean is the average. The mean is the average. So the high variance is data spread out. Data is spread out. Then the low variance is that data is clustered around the mean, around the average, right? So that is being said. We're still going to look at it deeper, and on Friday we will understand it probably more better, or Okay, yes, let me say more better because we'll be practicalizing it, but it is very okay for us to understand the theory behind it, right? So we have the high variance, we have the low variance. So we have the standard deviation as well. So standard deviation is the square root of variance. I know some people will be like, square root again. So it is not difficult. Like I said, you're not going to be writing on black and white. Your computer can handle everything in seconds. Even if you have 1,000 data, it can compute all these things in seconds. So you don't need to stress over that. Just understand how it works, understand how the computer does it, right? So it will be able for it to be easier for you to very easy for you to understand and to be able to manipulate and to be able to represent or perform some kind of operations because you have an understanding, right? So standard deviation, like I said, is the square root of the variance or the variance. All right. So moving on, this is an example. So in a consistent classroom, students have similar scores. That is low standard deviation. They have similar scores. So if scores varies widely, that's the standard deviation is high. It's very standard deviation. If they have similar this thing, that means their score, for example, if three people are 70, 71, 72, right? You see that their scores are very similar. There's a low standard deviation because if you find the average, their score is not far apart from the average. But if their scores are far apart, let's say 20, 60, 90, right? There's a chance that we have a high standard deviation. All right, moving on, correlation is also very important. It's also a statistical, some is also some statistics. Right? We also use it to, for we also use it for computations, right? So correlation measures how strongly two variables are related. What it does is just to measure how strongly, how related two variables are, right? So let's look at this example. So plus one is equals to strong positive. The height versus the weight, for example. The height versus the weight. The height versus the weight. Plus strong positive. Now we have the zero, no relationship. And then we have the minus one, strong negative. For example, the hours of TV watched versus your grade in school. So it is believed that the more time you spend as a student on the TV, it might negatively, although based on the course you are studying, it might negatively impact your grades. So that is a strong negative correlation. Okay, so what is the importance of correlation in machine learning? Correlation helps decide which feature to keep, combine, or remove. So in summary, it helps in feature selection. Yes, correlation helps you to select your feature, in your computation. So, for example, a business may notice that ad expenses increases while sales increases. So that's a positive correlation. Let me break it down. So let's say I have a business. Let's say I sell shoes and I pump in 1 million naira today. Let's say last month I pumped in let's say 100,000 last month, February, into my shoe business, and I made a sales of 500,000 at the end of the month. So let's say in April, or let's say in March now. Let me use it. Let's say in March, um I dropped 1 million naira for my business into my business. I invested 1 million naira and I made a sale of let's say 5 million naira. Right. So there's an increase in expenses, in ad expenses, and it led to an increase in sales. So that's a positive correlation. There's a correlation between the two. Because if I didn't invest that much, I wouldn't have gotten that much. Right. So there's a correlation, and that is a positive correlation. Okay, moving on. So when do we use each statistics? When do we use each statistics? So with the mean, like I mentioned, it is good for numerical data and symmetrical data. For numerical data and symmetrical data. While the median is used for the skewed data and the outlier resistance. The variance is understanding consistency, and the correlation is understanding relationship. So I want us to do an exercise quickly. Um, I want us to start with the mean. So I want you to drop. So if you hear mean, what comes to your mind? So just drop what comes to your mind when you hear the word mean. So based on what we've learned today, what do you understand by the word mean in your own understanding? So I'm going to call out some of the ones I see, and if they are 100% right, I'm going to say it is right. See if some need some little, maybe some little touches, I'm going to talk about it. So yes, Okai, if I'm correct, I'm sorry if I pronounced that wrongly. Okai said average, awesome, very correct. Um, Oluwatife said average, very correct. Abiola said average, very correct. Fisayo average, yes. Is there any other one aside from average? So when you hear the word mean, I think most of us, average comes to our mind that okay, we're calculating an average, we're looking for an average. To get the mean, we mean the average, which is absolutely correct. A round of applause for yourselves. All right, so let's move on to the next. So if you hear the word median, what comes to your mind? Median. Okay, somebody said middle. Okay. So when you hear the word median, what comes to your mind? Middle number, okay. Middle value, okay. Middle, okay. Middle, okay. So we have an understanding that when we hear median, we're talking about the mid value. The mid value, correct. So you are absolutely right. A round of applause for yourself because everyone is following and it's a very good one. We are all learning, right? So the third one, variance. So if you hear the word variance, what comes to your mind? Variance. Right? Someone said, "I don't forget." Don't forget to, because you would need this information in your practical class. So you can go back to watch the video to understand it better. And like I said, you can get resources online. You can also check ATC Vibes. You register, you go to the LMS section, and you would see my name. You enroll, and you can get more materials. You can also search online for PDFs that can help you. So just to, and you can also get this resource from Incubator as well. These are slides. You go over it again to really help you. All right. So variance. Somebody said variation spread. Hmm, okay. How much data varies from the mean? Awesome. Awesome. I think if Felua is really following, how much data varies from the mean? Square of standard deviation. Yeah. Yeah, because standard deviation is the square root of the variance. Beautiful, beautiful. All right. So let's continue. So the last one. So what comes to your mind when you hear the word correlation? What comes to your mind? Relationship. Beautiful, beautiful. Relationship. Yeah. So how are they related? Is it a positive relationship? Is it a negative relationship? Is it a neutral relationship? That is the plus one, minus one, and zero respectively. So relationship, when you hear about correlation, relationship is actually a very good explanation to what correlation actually is. Yeah. So I'm glad we're following. So a round of applause for yourselves, please. Yeah. All right. So the key takeaways: clean data is essential for any reliable machine learning model. Clean data is essential for any reliable machine learning model. Like I said initially, garbage in, garbage out. Whatever you feed your model with, the type of data you feed your model with is what is the equivalent result of that you would get after the model has performed the operations, right? So clean data is essential for any reliable machine learning model. So our next takeaway for this class is that summary statistics help you understand and prepare your data. The summary statistics helps you to understand and prepare your data. And our summary statistics, we have the mean, we have the median, we have the mode, we have the variance, the standard deviation, we have the correlation. So those were the six um, um, those are the six that we discussed today, right? So um, and thirdly, always explore your data before training your model. So you need to understand your data. I remember we mentioned the describe function, the what's the word again now? Info function, just to get the attributes, the properties, and the statistical analysis of your data set. So your data needs to be clean. Your data needs to be clean for you to run successfully a a good machine learning model. A good machine learning model. So I want us to do something really quick. If you want to, we have different types of data sets. We have the numerical. We also have the image data sets, right? We have several other types. So if you want to build an AI model today, which one would you build? Let's start with that. So drop it in the comment section. So we're going to take some of them and we're going to take more questions. So we are taking an AI and machine learning class, right? So after the 3 months training, you will have a full overview. You have the foundational knowledge of artificial intelligence and machine learning. So you are good to go to develop more and to build things, right? So if you'll be building a machine learning model, or let me say an artificial intelligence model today, what would you build? What would it be? So let's drop it on the comment section so we discuss. So we're going to take everything back to the beginning, which is our data. So let's take it up from what you build if you'll be developing a machine learning model or um, um, an artificial intelligence model today. All right. I hope we got the question right though. So the question is, if you have okay, it's coming in already. So let me just reiterate. So the question is, if you are to, as an AI ML student, if you are to build an AI model or a machine learning model today, what would you build? Okay, let's take the first one from Unwamata. I'm sorry if I pronounced that wrongly. So she said, training and testing data, which would be gotten from the data set. Okay, no. The question is, what would you build? What would you build? Okay, so um, Jackson said to take out ghost workers and bias in ministries. All right, that's a beautiful one. To take out ghost workers and bias in ministry. I'll take note of that. So, okay, another one, a model to predict food shortage in advance. Awesome, beautiful. To predict food shortage in advance. Okay, we're going to take probably the first five. So we have the first one, to take out ghost workers and bias in ministries. A model to predict food shortage in advance. Very good. This will help Africa. And Daniel said predictive model for traffic flow. Beautiful, beautiful. All right. Um, Agbola said, "Wetin I go build drug development." All right. So Folashade said, uh, I think I missed that. Okay, she said an app for prediction. Beautiful. Okay, to take out ghost workers in government ministry. All right, Mr. Jackson, got that. So we're going to still talk about it. I just want to read a few other ones so that we can now pick some and then we'll discuss about it. So where I'm driving at is that we need to understand the type of data we would need in training our model. These things are very, very much achievable, right? As long as we have the right data that we're going to use. So let's take more ideas that will now take one of some of them and then discuss about the data type that, or data set that will be needed. Okay, somebody said that's Olawole. So Mr. Olawole said analytical models for medical investigations. Beautiful, beautiful. Um, Ian Achor said crime data to predict hotspots of criminal activities. Beautiful. Joshua said medical diagnosis or predictive models. Um, CRM related to check client satisfaction. Beautiful, beautiful. He said, "Oh, I will build a chatbot." Yeah, we have a lot of them, but building another one will be a very good one too because probably you have something in mind that is different from what other ones are offering. So it's a beautiful one. Let me read some other ones before we now take a few of them and look at the data that we might actually need to achieve that. Okay, I can see a very beautiful one by Joshua. He said, malaria detection or weather prediction. Hmm, malaria detection or weather prediction, very possible. But then it all falls down to it all boils down to your to the quality, excuse me please, to the quality of your data set. To the quality of your data. So Deborah said something, said she said predictive trends in fashion or food consumption. Beautiful, brilliant idea. Beautiful. All right, recommendation system, beautiful. Um, a model that will help entrepreneurs in accounting, sales, and audit process. Awesome, awesome. A model to detect electricity theft. Beautiful as well. Beautiful. Detailed plan model for spreading the gospel. Beautiful, beautiful. Okay, how the distribution differs from the main. Okay, no, we've passed that. An app for forex trading. Okay, so Vincent, could you please explain more on how you want to bring in the AI model? So we might also take that to discuss the data that might be the data set that might be needed for that. Um, a model that detects cancer. Beautiful, Mrs. or Miss Yetunde. So a model that detects cancer. Beautiful. I actually worked on something similar to that. Or let me say I'm currently working on something similar to that. Yeah, and it's a very, very amazing project, seeing models that can actually detect if an x-ray has cancer or not, right? If a mammogram has cancer or not. So AI can do a lot of things, a lot of things. Okay, a model that will detect a fertile soil. Beautiful. This will really help, the farmers. But it all boils down to the quality of the data set. Quality of the data set. A model that can be used in agriculture, yes. Prediction of stability of engineering and civil structure, okay. All right, so let me pick out some in facial recognition model for attendance taking. Let's take that first. Now, Mr. Owamata or Mrs. I don't know, I'm sorry, but then a facial recognition model for attendance taking is a very wonderful project because we can see most of our, especially our learning institutions today, we don't have um, automated, especially the okay, don't let me mention names, but then we don't have a fully automated attendance taking system, right? We still do pen and paper, the class captain or the class rep or whoever will just come and fill and all those things. They are local processes. So we can have AI models that will scan the face and take your attendance, the time, everything, right? So in that, let's pick that now. In that kind of a project now for artificial intelligence, what type of data sets, what type of data set do you think will be needed? Let's drop that in the comment section. So I want to build an AI that would just take a picture of your, take the shot of your face, or probably via a live video stream, and then once it gets your face, it takes your record, it takes your attendance, and everything is seamless. So, what kind of data set do you think will be needed to train that kind of data? So, let's drop that in the comment section as well. Okay, the student's ID, okay, age, gender, okay. The data set containing the images of the students, that's also a very good one. So, an image data set will be very crucial in achieving this project. So we can train the model with thousands, millions of facial data sets with their information. Train the model such that once you feed the model, once there's a database of those this thing, the model can get your face and predict, oh, this is this person, this is this person. It can take probably the statistical data of the face, right? And based on that statistical data, it can use that to fetch the record, or probably even predict um, if you'll be late in a next class or something like that. So the AI would actually need a facial data set for it to work on, right? So to get that is actually a lot. Although we have some repositories that we can get data for the face that we can use to train the model to test and all those things before we now localize it to our own localized data sets, right? So I'm glad that we are following. So for that kind of a project, we need a facial data set. Yeah. So now let's take another project and also let's see the type of data set that we might need. Um, let me see. Let me take one of the projects that somebody dropped. Um, I think I saw something about um, accounting. And somebody said a model to predict to help entrepreneurs, accounting, blah 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 blah. So now that type of data set now, you don't even need, you don't need images. You don't need images. What you need is numerical data, historical data in finance, right? All those things, probably an audit document that has all this data, the statistics, the blah blah blah, everything. So you need more of numerical data in order for you to be able to achieve that model that can help entrepreneurs and statistical operations and all those things, finance and the rest. So numerical data is needed for that. So it means in order for you to train your model effectively to achieve that. So I'm glad we understand the topic. I'm glad that we've discussed so many things today. We talked about uh, um, cleaning of data, your missing